Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. What we're going to look at in section 4.6 are the graphs of the other three trig functions that we've covered. I know we've looked real in-depth at sine and cosine, and we've certainly graphed tangent a little bit as well, but we're now going to look at the three other ones and just kind of see how they look and what's involved with those. So, first one, f of x equals cosecant of x. Well, the one thing that I always like to do whenever I go ahead and go over graphing these is I like to include the graphs of their reciprocals. So, if we think about a sine wave real quick, starts at 0, then next critical point's a max, a 0 minimum, and then it ends back at a 0. Now, from here, what we're going to do is kind of like when we initially plotted these. We did go ahead and set up some tables. So, keeping in mind that when we actually are finding these, we're going to use the reciprocals. Well, I'm going to start certainly at 0. Well, remember sine, of course, is the y value. Well, what's the reciprocal of 0? Well, it's actually undefined. So what that means is we're going to actually have a vertical asymptote at 0. Now, I am going to go ahead and kind of like we've done before, I'm going to leave a space. We're going to use the 5 critical points, then we'll go back and fill in. Well, at pi over 2, sine's 1. Well, the reciprocal of 1 is 1. So those two points are going to correspond. Our next critical point at pi. Well, at pi, again, our y value is 0. Well, again, reciprocal of 0, just like over here at 0, was undefined. So you're going to have another vertical asymptote there. Now, at 3 pi over 2. Well, at 3 pi over 2, sine's -1. Well, the reciprocal of -1 is -1. So you also have a point there. And then at 2 pi, well, you've had a 0 here, a 0 here, a 0 here. That's also going to be a vertical asymptote. Now, again, using some points in between 0 and pi over 2. Well, what's our easiest option? Pi over 6, where the reciprocal of pi over 6, which was a half, is 2. And pi over 6 is kind of in that halfway, or not quite halfway realm. Then our next, between pi over 2 and pi. Well, again, let's use 5 pi over 6, where the reciprocal will be 2. Again, that's closer to pi over 2. And so what you end up with in here is a parabolic, kind of in shape, curve. Except you do have those vertical asymptotes. Now, if we look at a couple of points down here, let's go with 7 pi over 6, -1/2. Which the reciprocal of -1/2 is -2. And last, 11 pi over 6 for that in-between point there. Which also will have a reciprocal of -2. So, what ends up happening here, you have that kind of parabolic in shape curve pointing downward. So, cosecant looks like this. Now, as far as our domain, well, the domain is based off of what are the vertical asymptotes. So, let's come down here and say, well, the vertical asymptotes are x equals 0 pi, 1 pi, 2 pi, x equals n pi, where n is an integer. All right, your domain then is that x cannot equal n pi, where n is an integer. Your range. Range here is going to be a little different. You know, for this curve, now keeping in mind that these are going to, you know, you'd have another one up here, you'd have another one of these down there. Your range here starts at 1, goes up, here starts at -1 and goes downward, so does go to negative infinity. It stops at -1, it does include it, and then the next interval starts back up at 1 to positive infinity. Symmetry. Well, cosecant is the reciprocal of sine. Sine is an odd function. Any odd function is symmetric to the origin. The period. Well, the period of sine is 2 pi. The period of its reciprocal function, cosecant, is also 2 pi. You know, that's why the next one's going to be up here, or the next curve to the left is going to be down here. That's because it repeats every 2 pi. Your x-intercepts, well, this is kind of the real nice one. There are none. These black curves, again, we're not worrying about the sine wave, but these black curves will never cross the x-axis. Your y-intercepts. Well, because the y-axis is one of the asymptotes, there also are no, or is no y-intercept. You can only have one y-intercept. You can have multiple x-intercepts. So that's the graph of cosecant. Next up, secant. Well, again, let's go ahead and include and for this one, I'm even going to use -pi/2. Well, cosine wave starts at a max, 0, minimum, 0, maximum, and then over here you would be back at a 0. All right, so if we now set up our table, I'm going to go ahead and start it at -pi/2. Now, much like your cosecant graph, anywhere you had a 0 is going to be an asymptote for the reciprocal. So we are going to have an asymptote at pi/2, then at 0, well, the reciprocal of 1 is 1. So we'll have that point where the two graphs touch as well. Pi/2. Again, I'm going to skip those in-between values. Again, here we have a 0, just like at this 0. Secant will have an asymptote. Now at pi, much like the last one, reciprocal of -1 is -1. So the two curves have a point of tangency at the max and the min. And then 3pi/2 is actually where I'm going to stop this one. And again, at 0 you have, or at the 0 of cosine, you have an asymptote there. Now, in between points for secant. Well, let's go ahead and actually 0 to pi/2. Now your best options, pi/3, which is closer to pi/2 when we graph it. But the reciprocal of a half is 2. All right, so now if we come back, so that was pi/3. down here is negative pi over 3. It's also closer to that critical point. So negative pi over 3 will also have a value of 2. So you have, again, a kind of parabolic in shape when we sketch these. You know, we're not looking for anything exact, just kind of a rough sketch. Now, between pi over 2 and pi, well, your good option for cosine now, again, using the x values, is what would be 2 pi over 3. Now, it's closer again to pi over 2. And at 2 pi over 3, the reciprocal of negative a half will be negative 2. And then one last, between pi and 3 pi over 2, our convenient x value, 4 pi over 3, which is closer to 3 pi over 2, will have a value of negative 2. And again, you have a, at least kind of parabolic in shape. It's actually a little bit flatter curve than that, but for what we ask you to do, those rough sketches there are fine. Now, talking about all of the critical attributes, again, let's actually start with vertical asymptotes. They are x equals negative pi over 2, let's even say negative 1 pi, 1 pi, 3 pi, the next one would be at 5 pi. So, x equals n pi over 2, where n is an odd integer. So, domain x can't equal that. As far as the range goes, well, we've discussed how sine and cosine are just shifts of each other. Well, cosecant and secant are also shifts of each other as well. So the range of cosecant will be the exact same range for secant. All right, the symmetry. Well, cosine is an even function. Its reciprocal is also even, which means symmetric to the y-axis, which, you can see this curve, well, in theory, this curve would be reflected over the y-axis. My sketch, not so much, but again, it should be. Period. Well, cosine is a periodic function with a wavelength of 2 pi. Period of secant is also 2 pi. Up here, you'd have the next one of these upper curves. Over here, you'd have the next of those lower curves. X-intercepts, well, again, the black graphs, again, not worrying about the red cosine wave, but the black curves never cross the x-axis, so they have no x-intercepts. There is a y-intercept at 0, 1. So there are your cosecant and secant waves. The way I always even think about these, I actually always will draw in the cosine or sine wave, and then basically all you have to do, sketch in your asymptotes, and then you can just draw those curves that are tangent at the maximum and minimum. So, all right, before we graph cotangent, we're going to come back, talk a little bit about tangent. Tangent is sine over cosine. And so from here, in terms of graphing tangent, I'm going to even go all the way back to negative pi over 2. And then in the middle, negative pi over 4, 0, positive pi over 4, pi over 2, and then in the middle, again, let's see here, find one that's not running out of ink. 3 pi over 4 pi, and much like 5 pi over 4 is your middle value, and 3 pi over 2. When we actually cover section 4.7, you'll see the reason why some of these we do go back to negative pi over 2. Some of them we actually go 0 to 2 pi. So with tangent, negative pi over 2 is down here. If you take y over x, negative 1 over 0 is undefined. Negative pi over 4. The y over the x will be negative 1. At 0, y over x is 0. At pi over 4, my y over x is 1. And pi over 2, when I take 1 over 0, it's undefined. So that's our next asymptote. So the curve ends up going through there, kind of again, kind of like a cubic shape. All right, so pi over 2 is our asymptote. Now at 3 pi over 4, y over x, negative 1. So we're now back down there. At pi, 0 over negative 1 is 0. At 5 pi over 4, y over x, since they're both negative, is positive 1. And then, since negative pi over 2 and 3 pi over 2 are the same thing, we are back at our next asymptote. All right, so it's in theory, mirror image of what we just did there, because tangent has a period of pi, which means we can even, if you want, fill in down here, cotangent's period's pi. We've discussed all of this for tangent already. That's why we do not have any of this for the cotangent graph. Now, for cotangent, we can actually start this one back at 0. And then I will use those same pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 values. Now, at 0, tangent's y over x, cotangent is x over y. So there it's your first asymptote. So again, we'll just kind of try to sketch that as best we can right next to it. Pi over 4. X over y is 1. Pi over 2, x over y is 0. Three pi over 4 is x over y, negative 1. And then at pi, x over y gives us an undefined asymptote. So, main difference here is you have a downward curve from left to right. 5 pi over 4, I mean everything's just going to repeat. 1. 3 pi over 2 is 0. 7 pi over 4, negative 1. 2 pi is your asymptote. This is where use the fact that it's a periodic function. Saves you some time even filling in the table. All right, so again, with these, I always like to start with my vertical asymptotes. X equals 0 pi, 1 pi, 2 pi, n pi, where n is an integer. So that means for domain, x cannot equal n pi, where n is an integer. Your range. Well, these curves are continuous, negative to positive infinity. Symmetry. Both tangent and cotangent are odd functions, so the symmetry is the origin. Meaning, if you rotated these 180 degrees, this will mirror onto itself. If I rotated this 180, you'd have another one over there. So, that's that. The y-intercept, might as well start with the easy one. Never crosses the y-axis, so there is none. Your x-intercepts are 1 pi over 2, 3 pi over 2, there'd be one at 5 pi, negative 1 pi, so they are n pi over 2 comma 0, where n is an odd integer. So this completes the graphing of all 6 trig functions. Again, the 2 that we actually ask you to do a lot with, sine and cosine. Tangent and cotangent, you need to be able to certainly recognize those. Same thing with cosecant and secant. But again, that completes everything out of 4.6.